Welcome to the gas mass bag lab. You're going to have a bag. You're going to have a stopper that has a hole in it. There will be a little rubber bulb on the end of a glass cylinder that goes through the stopper. And notice that the cylinder goes all the way through. And that is just meant to, the bulb is meant to stop air from going through, or any gases from going through that hole. And you're going to have a rubber band. Your job today is to mass gases, but there's a problem. Archimedes' principle tells us that you will, if you're in a fluid, and this room is full of the atmosphere, and the atmosphere is a fluid, if you're in a fluid, you will weigh less than if you are in a vacuum. If you're in a fluid, you have buoyancy. You will weigh less, equal to the weight of the fluid that you displace. So, for instance, if I displace 10 grams of air, then on a scale, I will appear to weigh 10 grams less than if I'm in a vacuum. So that's the problem with this lab we're trying to solve, is that we're weighing gases in a gas. And the gas itself, which is the atmosphere, is going to make the gas in the bag appear on the scale to weigh less because of buoyancy. Thanks, Archimedes. Jeez. Now our job is to do some mathematics and try to figure out what the mass of the gases in this bag are. And first thing you got to do is weigh the rubber band and the stopper and the bag and everything. And so you're going to come over to your scale, and the reason that there's a bowl on your scale is to keep everything from rolling off, keep things confined. So make sure that your scale is zeroed with the bowl on there first, and find the mass of all of your stuff. Write that mass down on your lab paper. I'm deliberately not showing you my mass, so you won't write my mass down. Write your own mass down. One of the hardest things about this lab is getting your stopper in the mouth of the bag in a way that doesn't choke the end of the stopper. It's easy to wind this up really tight, and then air won't flow through there. So the method I use is an accordion method, where you put the stopper in the side of the bag and then fold the bag about an inch, inch and a half, and then fold it the other way, sort of in an accordion style. So you're zigzagging and zigzagging. When you get close to the stopper, push it up against the stopper like that. You want to be able to see the hole in the bottom of the stopper. And then grab that rubber band, get it as tight as possible, twist it, go back around, twist it, go back around. And your test to see if you've done this well is to take the bulb off the end of the glass cylinder and push all the air out. Does air exit your system completely and easily? If so, you've done a nice job. I'm going to give you a quick tour of the lab. Here is the methane gas. You'll find the methane. It comes out of the same valve as for the Bunsen burners. And to fill your gas, this is the only one I'll demonstrate. To fill your bag, of course, evacuate it first and turn the methane on. Try to seal that with your fingers. The methane smells really bad. It's doped with hydrogen sulfide so that it smells like rotten eggs. And because we can't smell methane on its own, we don't know when it's leaking, when it's a fire hazard. So we put another stinky gas in there so we know when there's a leak. And the room will smell really bad if you let a lot of this stuff leak into the room. So I'm just filling the bag until the bag is as full as it can possibly get. And for each of these gases, you want to fill your bag the same amount for each of the gases. That's going to be one of your controlled variables. All right, that's as much as it'll fill. I'm going to stop my gas, plug the hole, and cover the stopper. Bring it over to the scale again. Of course, zero the scale and place the bag on there. With the heaviest thing on the bottom will probably work best. and find your mass of your methane. It should be different, hopefully, than the mass of the bag and the stopper and the plug. Here's the air. The trick about using the air is that if you turn this up all the way, water vapor is going to come out and you'll ruin the experiment and you'll ruin the bag for all the other classes today. But if you turn it on just barely enough that you can hear it, then no water will come out, and the air value should have a similar humidity to what's in the room. And that's what we're trying to measure. There might be some error with the air. Ba-doom. The other gases are over here. We've got oxygen, we've got hydrogen, we've got some carbon dioxide, which we might run out of today, or maybe we'll run out of the oxygen, we'll see. But of all the gases that we have, you need to make sure that you've been taught your whole life righty-tighty, lefty-loosey. So it should be righty on, lefty off. Or righty off, lefty on. I just confused it myself. But regulators are different. They're righty on, turns the gas on, and then, you heard that, and then lefty off, turns the gas off. And so that's a tricky part. Your teacher will hang out by the gases today to make sure that you don't waste any of the gases. Also, be careful to pull the glass tube for your stopper away from the hose before your bag pops. It's not really, a big deal, but you'll have to redo that part. All right, I think that's pretty much everything you need to know, except for where do you find the pressure and the temperature in the room. And I just powered this up right now, but our LabQuest here in the middle of the room will tell you the pressure and the temperature. You might have to do some conversions, but everything here is what you need. Good luck today. Have fun.